Hello, my dear students. Very good afternoon. How you all are doing? Hope you all are doing fine. Fabulously good. Today is the second session for YouTube Live motion in one dimension problems. Okay. This happens to be the second session, right? In fact, in this particular session, I'll be focusing majorly on the problems from. This happens to be the second session, right? In fact, in this particular session, I'll be focusing majorly on the problems from. Yeah, so accordingly, I will just move ahead with the problems here. Okay. So as we all have seen some 6 or 7 good quality problems yesterday, today we will focus once again on such good varieties of problems. Okay, and then this chapter, like in this particular chapter, what all important problems are there? Those I would have covered. Okay, so within next 20 odd minutes, let's go ahead and focus on all these things. Okay, but prior to that, let me just wait for some time so that all of you can go ahead and join for this particular session. Fine. So let us just wait for some time. Good afternoon, Ananya. Very good afternoon. Prasanna, very good afternoon. Hope the audio quality is good. You all can hear it properly. Otherwise, you please let me know whether it is good or not. Audio quality. Okay. Anyways, I'll connect the. Now you just cross verify whether it is correct. Okay. So dear friends, let's straight away go ahead and begin with our discussion here. So this is my brief profile for your perusal. My name is Uttam Kumar Umarji. In fact, I am your personal physics teacher with 19 years of experience. I am presently number 2 educator in Karnataka CET. And in order to unlock your plus subscription, use the referral code UTTAMLIVE. This is my referral code for your perusal. Okay, fine. Now let us just move on with our discussion here. Now, talk about in brief about my experience. I have taught JW Advanced, JW Main Physics for closely for about 19 and odd years at Delhi. I began my career at Kota actually, and then I shifted to Delhi, then Bangalore, and I have worked all across India, almost every place, every major cities in India. I have taught to the students. In fact, I have taught closely to 10,000 plus students till date, my dear friends. Thanks to all those students that right now I am enjoying my tenure at Unacademy. So, this is presently my 4th month on Unacademy, and I feel really happy about that. Now, let me just move ahead with what Unacademy can offer to each one of you. Now, Unacademy has got a plus subscription plan for you all, and this plus subscription will give you all those things combined within one package. Now, like for Karnataka CET, we have this particular offer. These are the best plans that are available for Karnataka CET 2021 aspirants, and first plan would be like best plan would be 12-month plan, and this 12-month plan this would cost you 12,375 rupees. And over here, remember that this 12,375 rupees, you can also go ahead and make the payment in easy monthly installments, like 1,031 rupee per month. Okay, then you have a 6-month plan. For 6-month plan, you can go ahead with 10,125 rupees. Now this is a package plan for 6 months, and you can avail EMI facility by paying 1,688 rupee per month. Okay. Then we have a trial plan. This is a 1-month plan. Now this plan will enable you to go ahead and try Unacademy Plus subscription. Then you can enhance your subscription. Okay, so over here this 1-month trial plan is only for new subscribers. Please bear this in mind. Okay, then with reference to these all things, what we will get, like suppose you pick up a 6-month or 12-month plan, what you will get out of it? Now definitely you will be getting a premium content at affordable price. Then structured live courses would be there. Definitely it's a structured live course program, and here you will have dedicated live doubt clarification sessions. Okay, for your information, my dear friends, after every 3 plus classes there will be one doubt clarification session, and this live doubt clarification session, it is especially meant for you all to clarify the doubts regarding that course that has been covered in those 3 sessions. Okay, so in fact this is one of the beneficial thing that you will get here. Then quizzes are conducted regularly, and why quizzes are conducted? For self analysis. This is again important thing. Then for complete preparation only we are giving the batches. The batches are there for complete preparation, my dear friends. And then we have DPPs, daily practice papers. Okay, then full length mocks we have. And everything will come with a handy analysis. Now this analysis will definitely make you understand where you exactly stand, is it not? So this is where like we can go ahead and talk about the analysis part. Okay, so I hope it is clear. Then one single subscription can provide you unlimited access. Now this is again, I can say that like you will get everything out of almost a small amount of price subscription, right? So presently we have a comprehensive batch which is live here. Okay, you can join that batch. You can go ahead and subscribe for that particular batch. Okay, and then you can here use the code UTTAMLIVE as your referral code, my dear friends, in order to avail a 10% discount. Suppose you want to avail a 10% discount, go ahead with UTTAMLIVE as your referral code. Okay, thank you for your time, precious time being given to understanding to understand the plus subscription of our Unacademy plan. Now let's begin with our discussion, my dear friends, quickly. Now, first question: a particle starts from origin at time t is equal to 0 and moves along the positive x-axis. The graph of velocity with respect to time is shown in the figure. What is the position of the particle at a time t is equal to 5 seconds? Now they are asking you to calculate find the position. Position in the sense how much displacement this particle has made at time t is equal to 5 seconds. That is what they are asking. So simple thing would be what? Area under VT graph. Now this is the VT graph. Okay. Now area under VT graph up to t is equal to 5 seconds. If we find this area, then we would have found our answer here. Okay, so that is the approach that we can adopt for this particular question. So let's go ahead and crack this question. And as a matter of fact, this question, it is from JMain. JMain, a recent 2019. This question has appeared, my dear friends. Okay, so now over here to get exact position at t is equal to 5 seconds, we need to calculate area of the shaded part in the curve as shown below. Now obviously here we have displacement of the particle is equal to area of triangle OPA plus area of square PABSP plus area of rectangle QBCRQ. Okay. Now this is what we are going to obtain here. Fine. So simply you just calculate the net area. Net area is found to be 9 meter here. You can go ahead and make a calculation of that. Now as you all can notice here, now let me just go back to this diagram here. Now here we have one triangle, is it not? Let us go ahead and find area of this triangle quickly. Let me just erase this off. Now for this triangle, firstly we will find area of this triangle. Okay. Now area of this triangle is half into base into altitude. Altitude is 2, base is 2. So 1 by 2 into 2 into 2. So obviously this should get the area as how much? 2. Is it not? Next, second step, we'll find area of this particular square. We'll find area of the square. So which is 2 to 4 means here base is 2 and edge length of the height is obviously 2 here. So 2 2s are, we'll get this as 4. Okay, 2 plus 4 plus area of this rectangle. Now we should find area of this rectangle. Now area of this rectangle, we know that base is 1 and our height is how much? 3. So 1 into 3, 3. So 3 plus 4, 7 plus 2, 9. So we will get the final answer as 9 meter here. So hence we can pick option D as the right choice here. Is it not? Okay. Quickly let us progress to next question. The question number 2. A car moving with a speed of 50 km per hour can be stopped by brakes after at least 6 meters. If the same car is moving at a speed of 100 km per hour, the minimum stopping distance is. Okay. Now, firstly, initially car is moving with speed of 50 km per hour. Okay. So obviously here U1 is given to us. Then in this particular case 6 meter, after traveling 6 meter distance, car is getting stopped. So that means V1 is 0 here. Is it not? Then they are asking if the same car is moving at a speed of 100 km per hour. So obviously this happens to be what? U2 here. Minimum stopping distance they are asking. So very clearly we will find the relationship between initial velocity and displacement. That's all. Then we'll get the answer here. Is it not? So here firstly I'll mention this formula for case 1. U is 50 km per hour. So into 5 by 18 I am making to convert it into meter per second. Then V is 0. S is how much? 6 meter. And acceleration I am taking it as A here. Then in such case we'll get V square minus U square is equal to 2as. So obviously 0 square minus 50 into 5 by 18 square is equal to 2a into 6. So obviously we'll get this as what? 50 into minus 50 into 5 by 18 square is equal to 2 into a into 6. Is it not? Now next step, for case 2, 100 km per hour it is given. So 100 into 5 by 18 meter per second. V is 0 here. S is equal to unknown. I am keeping it as S only. Then acceleration I am taking it as A again. Then again by using formula V square minus U square is equal to 2as. Here I will get this as what? Minus 100 into 5 by 18 square is equal to 2 into A into S. This is second equation. Now let us divide these two equations. So next step, divide equations 1 and 2. We get 100 into 100 by 50 into 50 is equal to 2as by 2a into 6. So clearly 50 ones are 50 twos are here, then 50 ones are again 50 twos are. So, and on this side I can cancel off 2 and 2, a and a here. Then we are left with what? S by 6. Okay. So therefore I can say that S is equal to 6 into 4, that will be 24 meter. Okay. So that is the answer that we have. Now let us move on to third question. The coordinates of a moving particle at any time t is given by x is equal to at alpha t cube minus and y is equal to beta t cube. Okay, the speed of the particle at time t is given by, okay, so we should calculate speed of the particle at time t. So now over here, first thing, x is alpha t cube, y is beta t cube. So accordingly I'll mention vx I'll find first. Okay, velocity along x-axis, vx is dx by dt, which will give me 3 into alpha t square. Similarly, vy, that is velocity along y-axis, is what? Derivative of y with respect to t, so which is dy by dt, that will be 3 into beta t square. Okay. Then, therefore, velocity, resultant velocity is what? Square root of vx square plus vy square. That is resultant velocity here. So that is 9 root of 9 alpha square t fourth plus 9 beta square t fourth here. Are you okay with this? Comfortable now? Okay. So now accordingly I can, next step I can write here 3 t square comes out as common out of the square root. So we'll get this as what? 3t square into square root of alpha square plus beta square. So this is the final value of velocity. Okay. So that was question number 3 for you. Now let us talk about question number 4 here. Okay. I have taken a question from JMA 2008. Okay. A body is at rest at x is equal to 0 and at t is equal to 0 it starts moving in the positive x direction, okay, with a constant acceleration. At the same instant another body passes through x equal to 0 moving in the positive x direction with a constant speed. The position of the first body is given by x1 of t after time t, and that of second body is given by x2 of t after same interval of time, that is after time t only. Which of the following graphs correctly describes x1 minus x2 as a function of time? Okay, now what is x1 minus x2, my dear friends? Is it not displacement? Okay, so we should draw or we should find a proper displacement time graph here. That is the approach that we have to adapt here. Okay, so accordingly I have brought back this graph for your reference. I hope it is visible to everyone. Okay, fine. Now as you all can see here, for bodies starting from rest, x1 equal to 0 is initial velocity is 0, no? x1 equal to half at square I will write. Okay, so this is x1 value that we have. Then for body moving with constant speed, x2 equal to vt I will write. Is it not? Starting from rest, u is put as 0, whereas if the body is moving with constant speed, x2 will be equal to what? V into t. Simple, right? Then therefore x1 minus x2 equal to x1 minus x2 equal to, simply take the subtraction of this half at square minus vt. So that means, can I write it as d of x dy dt of x1 minus x2, is it not, is equal to at minus v. So what I have done here, I have differentiated on either side of this equation by with respect to time. So that is what I have obtained here. dy dt of x1 minus x2 equal to at minus v. Okay, so at t is equal to 0, I can see that if I put t is equal to 0, I see that x1 minus x2 becomes equal to 0. Is it not? In this equation, put t is equal to 0. Then we'll get x1 minus x2 equal to 0. So that means our graph is starting from origin only. That is what it means. Okay. Secondly, for t less than v by a. Okay. So if I take t less than v by a, the slope is negative. Now let me just go back to this particular equation. So as you can see, dy by dt of x1 minus x2 will give you what slope, no? dy by dx is called as slope of graph, no? So for xt graph, dx by dt is going to be what? The slope of the graph. Now in this particular case, if you want to calculate the value of slope, then remember v by a, t equal to v by a or t less than v by a we should consider. So for t less than v by a, slope becomes negative very comfortably, we can say that. Okay, so hence for t equal to v by a, the slope is 0. So that means the curve is intersecting the x-axis. Okay, for t greater than v by a, slope is positive. So hence from these all things we can see that this is our perfect graph that we can plot. Okay, so this graph, as you can see here, at t is equal to 0, x1 minus x2 is 0. At t less than v by a, as you can see here, t is less than v by a. For t less than v by a, this region here, it is slope is negative, and for t equal to v by a, as you can see, slope is 0 here. Then for t greater than v by a, the slope keeps on increasing and slope is positive there. You can comfortably understand from this particular graph. Okay, so hence our required graph is this particular graph that we have seen here. Next, fifth question. Okay. A particle starts sliding down a frictionless inclined plane if Sn is the distance traveled by it from time t is equal to n minus 1 second to t is equal to n second. The ratio Sn by Sn plus 1 is, okay. Now Sn is equal to, we know that it is a by 2. Sn is given as a by 2 here. A by 2 into 2n minus 1. This is the formula that I know. This is displacement made by the particle in nth second. Now this formula I am utilizing. Sn is equal to a by 2 into 2n minus 1, because here initial velocity is 0. Remember, so if initial velocity is not 0, then we write this as what? Un plus a by 2 into 2n minus 1. Okay, so over here we are putting u as 0, initial velocity is 0. So that is why, let me directly write the formula like this. So then Sn plus 1 in this case, Sn plus 1 is equal to a by 2 into bracket 2 into n plus 1 minus 1. Okay, so obviously here n equal to n plus 1, no? Time is equal to n plus 1 here. So hence 2 into n plus 1 minus 1. So hence we will get again this as what? A by 2 into 2n plus 1 we will get. Okay, if you take the ratio here, then I tend to get the ratio as 2n minus 1 upon 2n plus 1. Okay, I hope it is clear. Now let me just move on to next question quickly. Sixth question. The displacement of the particle varies with time according to the relation x equal to k by b into 1 minus e raised to minus bt. Then the velocity of the particle is. Okay. Now in this particular case, displacement has been given. Now we should find velocity. Simple. So we'll just go ahead and differentiate it. So v is equal to dx by dt. So thus I can write it as d by dt of k by b into 1 minus e raised to minus bt. Right? That is the equation given to us. So accordingly I am writing it. Now if you just differentiate it with respect to time, then I tend to see that k by b is constant, so it is out of the derivative, into derivative of 1 is 0 here, then derivative of e raised to minus bt is minus b into e raised to minus bt, and outside we have 1 minus. So accordingly I'll get this as k, because this 0 minus of minus plus b will get, no, so this b and b can be cancelled off, thus we'll get velocity equal to k into e raised to minus bt. Okay, so this is the velocity equation, my dear friends. Next, seventh question. The acceleration of a particle starting from rest varies with time according to the relation a is equal to minus of a omega square sine omega t. The displacement of this particle at a time t will be. Okay, now over here, this is velocity. From velocity to find displacement, we'll simply integrate the velocity equation. Now over here they have given acceleration to us, so therefore velocity v is equal to integral of acceleration that I am doing here. So accordingly acceleration is given as minus a omega square sine omega t into dt. So right, so I am just going to differentiate this. Now as you can see, I'll get this as integral of sine omega t is minus cos omega t by omega, minus of minus plus. So thus we'll get this as a omega cos omega t. Okay, so this is the velocity that we have. Okay, displacement we should find here, right? Okay, then accordingly displacement again it will become what? Integral of velocity. So therefore I'll write this as v into dt. So v is a omega cos omega t. So very clearly cos omega t, integral of cos omega t is sin omega t divided by omega. So and omega cancel off here. So thus we'll get the integral as what? A sin omega t. Okay, so that is the displacement, my dear friends. Okay, so I hope this particular session you all liked it. Okay, so let me just wind up today's session, because right now the half an hour time that has been given to us is over. So I'll stop my discussion at this point, my dear friends. Okay, so let me just meet you back in my next session tomorrow. Not tomorrow. In my next session on 9th of this month, we'll meet back on 9th with YouTube live session. So until then, my dear friends, I'll see you all once again on YouTube. By then, take care. Have a wonderful time. Thank you very much. Okay, fine. So let me just wind up now. Suresh Kini has asked me a question here. I'm sorry, in the flurry of problem solving, I didn't answer to you. Suresh Kini, you are asking, sir, any news regarding KCET 2021? As of now, Suresh, no info has been given to the given to us regarding Karnataka CET. Okay, but definitely there will be KCET session. Okay, it will be there, but when and at what month, in what month, or when exactly, it has not been announced yet. So most probably by the end of this month we will get to know exactly like when Karnataka CET exam will be scheduled, my dear friends. Okay. So okay, Suresh, I hope I answered to your question. So do you have any queries regarding today's session? And Sangeeta Shetty. Okay, you answered option B. Okay, okay. Thank you very much. Then fine. Then I'll just see you all once again in my next session. Until then, stay tuned with Unacademy live on YouTube. Thank you very much. Have a nice time. Bye.